honor na to be part of this learning session. And I'm proud to share to you of what technology, the latest technology about UVGI systems as part of ACMV auxiliary. So nowadays, because of this pandemic, I'll be very happy to share with you the benefits, the principle of how it works, and a lot more of the what are the things that you need to look for when you are buying a UVGI system or you wanted to use it in your ACMV system. So I think I'll be turning off my video and I'll be sharing my screen. Sir Gabriel, great. I can now share my screen. So is it clear and is it readable from your side? My screen, is it readable?
Yes, ma'am.
Yan, great. I think,
Yes, ma'am.
sige, mag-set up lang ako ng pointer. Mhm. I don't know, but di ako makaset up. But can you see my cursor also moving? Can you see my cursor moving?
Yes po.
Okay, great,
Yes,
great.
yes, ma'am.
I'll just use my cursor for pointing any important details that I wanted to emphasize. So good evening again. So we will be tackling now the UVGI or the ultraviolet germicidal irradiation. So since I'm connected with Envirotech, so I have put in here our company logo. So just a bit background about Envirotech Systems. So the company has been in the market for more than 15 years now, and our managing director has been in the industry for more than 30 years, engaged more of HVAC system or ACMV, focusing on indoor air quality systems, humidity control, and energy conservation. So we have few innovative products that is our own brand, and all of them are all third-party tested with certification. So our factory is in Shah Alam, Malaysia. It's within KL, and 50% of our products manufactured there are being exported international, ASEAN, or even the US, Middle East, and other parts of the world. So these are the few of our products that we manufacture as our own. These heat pipes, UVGI, which I will be sharing with you tonight, Zener electronic air cleaners, and purifier. So Trian is bought out. It's a brand that we distribute. So we don't manufacture it. We buy it and we sell it out. So to start with, as everyone is engaged for HVAC system. So we all know this actually, that the HVAC system is the lungs of the building. So if it's the lungs of the building, this is where we also breathe whenever we are indoors. Okay, so that's why it's a very big factor to our health. So the thing is, where does the air? So we are also aware that air passes through this cooling coil, right? This is part of the air conditioning system. So as time goes, this part of the air conditioning system gets choked with like a slimy material or biofilm. We call it biofilm, where bacteria, molds, fungus are built up. So that means whatever bacteria or any viruses that attach to this part of the system, this cooling coil, can be carried over to the supply air. So that's where sick building syndrome starts. So people indoors gets to feel headache, feeling no shoes, feeling like itchy throat. So these are the simple symptoms of the sick building syndrome. So the thing is, there's a good news because UVGI system can help to prevent the spread of these microbes in the air. So the UVGI system has this 254 nanometer. There are different types of ultraviolet, but the UVC is being used for germicidal irrigation. So UVC, it how it works is that it kills the microbes itself by destroying its DNA. So that means it cannot replicate anymore. Okay. So this has been this slide has been published last year from ASHRAE Journal. It says that the velocity of the air affects the spread of pathogens in the air. And they have discovered that they have swabbed the surface of the exhaust air duct and they found out that the presence of SARS-CoV-2, which causes COVID-19 disease. So that means it's true that this virus can be present, can be recirculating in the system. Okay, and of course, WHO admits now that it is airborne. Okay, and good thing is that ASHRAE, since last year, they have actually they have published a position document. One of those recommendations is the installation of UVC in aircon systems to prevent the spread of coronavirus. So they have recommended it to both build healthcare buildings. Okay, putting of course there are different recommendation of how we can improve indoor air quality, better indoor air quality, and one of those is to install UVGI. So the same thing with non-healthcare building. ASHRAE has recommended to install UVGI and improve your filtration system. Okay, so the thing is, how does virus move? So virus doesn't move alone. It moves with particulate matters. So it's like dust or any droplets in the air. It can be attached to those kinds of particulate matter. So that's why the filters has also a role of minimizing or reducing the spread of the virus. So you can see the virus can be as tiny as 20 to 400 nanometer. And actually, the SARS-CoV-2, it's in the recent studies, its size can be as small as 0.1 micron. Okay, it's even less than the it can even pass through HEPA filter, you know. So this is how the representation of different particulate matter of PM1, 2.5, and 10. So through these matters, virus can be attached and can spread. Okay, so this is just a representation also that of course the bigger the particle is, the faster it can fall down, and the smaller the particle is, the longer the time it can stay up in the air. That's the reason of being transmitted through airborne. So the thing with virus is that, say for example, initially it can be a big droplet, but as time goes by, the virus stays there as a dry nuclei and it flies or it just stays suspended in the air. So its life is quite long, no? That's why like places like train, air-conditioned space, it is really, we have really to be very careful. So that's why we are always mandated by the government that we always wear mask, because wear mask that is 95% or it's like a medical grade, so that, you know, for us to be safeguarded from this airborne. So this is an example of how transmission works. So of course, when a sick man in the air-conditioned room coughs, of course, bigger particles drops, and the smaller ones goes back to the air conditioning, the recirculating air conditioning system. And if you don't have any proper filtration and UVGI, it can go back to the room. So that is why it is highly recommended that you improve your filter system and install UVGI. So this is also from, this schematic drawing is also from ASHRAE Journal. So it says here that this room with red, this first box is where a contaminated person, a patient, say for example, a COVID patient is housed in. And then there are different rooms also sharing the same air handling unit and the same exhaust duct. So the thing here is the room which are clean, say clean that it is no patient. They are these are clean rooms can get contaminated at around 3 to 8 minutes. That's how fast that the rooms can get contaminated. We call this cross room contamination. So we as engineers, this I think this we have to be very aware in our design, in the buildings nowadays, that that we have to improve or suggest to the management of the improvement that that can be done to prevent the spread of uh, airborne airborne disease like COVID. So the next question is, if UVGI is the solution for better indoor air quality, how much UV can kill the germs? Okay. So there is what we call UV dosage, which consists of UV intensity and exposure time. So actually, UV dosage really varies to these two factors. No? This is the recent study of the dosage that is effective for SARS-CoV-2. So this was done by Kowalski and his group last year. So you can see here there are two SARS-CoV viruses, okay, and the average of dosage is at 27. So you can see here D is the dosage, 90 is the elimination rate for the virus. So that is how we translate this D90. So joules per meter square is the unit, okay? So that means at 27 joules per meter square, there was 90% elimination rate of the SARS-CoV-2. So what is the importance of that dosage? This is a shoulder curve which shows that the higher the UV dose, the lesser is the survival fraction of the microbes. So let's see, this 27 is around here. So 27 means more than 90% elimination rate. Okay, so you can see here it's 0.1, it's around 97 or more than 90%. So that means it coincides with the actual testing that at 27 joules per meter square, it can really kill at that efficiency. So this table is the UVGI rating value. We call it URV table. This is this was formed by International UV Association, and it is also included in the UVGI handbook by Kowalski. So you can see here, the gray area is the nominal design range, which is being used commonly in the market. Okay, so you can see here it's like MERV rating. It's like if you're when we talk about filters on the MERV rating, my MERV 6, 7, 8 and up, and 215. So the same way with URV rating, they have identified the numbers with corresponding dosage. So say for example, and this dosage corresponds to the air disinfection rate for these two viruses and these two bacteria. So say for example at URV10, you are having for the influenza, which is close to COVID, let's say, you are having 45% disinfection rate at single pass from UV alone, from UV effect only. And for the TB, which is very common for hospital and MRSA, you can have 90 or 95% elimination rate using this URV rating. So the thing is, the UVGI provider will have to select the UV lamp length and quantity to achieve this URV rating. Okay. So with dosage of 27 joules per meter square, it's between URV 13 and URV 14. So you can see here, the elimination rate for influenza, which is close to COVID, is around 91%. Which is, if we can look at the other, this table, this actual test result, it's 90%. This D90 is at 27. So around 90% elimination rate. So that means it coincides also to this table. Okay. So this one is a table for the filters. I will show you later the example, the importance also of improving your filters. Okay. So this is an example of calculation of total removal rate using MERV 13 and URV 13 for MRSA bacteria. So say, for example, you have an initial population of 1 million. So passing through MERV 13 has an average of around 85% removal. Okay. And after passing through MERV 13 with URV 13, the table has around 99.9%. So you can have around 99.9%, almost 100% removal for the MRSA. So let's apply for SARS-CoV-2. For UVGI only at URV 13, you can only have 90% removal rate for UVGI alone. But if you will couple it with MERV 13, MERV 13 has an initial removal rate of around 85%. So initial passing through of the air has eliminated 85%, and then passing through another 90% of elimination rate, you can get around 98.5%. So why are we saying this? Why are we sharing this? URV 15 can be a lot more when it comes to first cause. And if you, it's the standard for the buildings, for your air handling units, that you have a MERV filters. So why not optimize that and couple it with your UVGI system, so you can get a better result of microbes elimination. Okay, but of course, if your customer really insists that they wanted URV 15 because they wanted to have around 99% elimination rate, then it's up to them. But of course, we are here to share to them that they can, it may be cost effective for them to use a little bit lower URV rating. But of course, it is effective. So this photo reactivation is it is how the UVGI kills the DNA of any microbe. Okay. So of course, there are classifications of the buildings where we can use UVGI system. So for healthcare buildings, we are very much concerned of the patients and the visitors and the staff of the building. And of course, the causes of, there is this what we call hospital-acquired infections. So this is the thing that, when you enter the hospital because you need to have a knee surgery, you don't have any respiratory problems, but you came out from the hospital having fever, having cough, or any respiratory system disease. That is what hospital-acquired infection is. So that means the indoor air quality of that hospital is very poor, that it causes more sickness to the people inside. Okay. So that is very important where to use the UVGI system. So there have been a lot of proof that these hospital-acquired infections are present, are happening. Okay. And other non-healthcare buildings, of course, offices, malls, cinemas, educational institution, any manufacturing plant where a lot of people are indoors. Of course, we are protecting the visitors, the staff employees of the buildings. That's why we wanted to prevent this building-related infection. So this is the thing that it's like a sick building syndrome also. Okay, like one of your office mates came with fever or cough, and then the next day you were also having it. So that is what building-related infections are. Okay, so there are also some disadvantages because of this heavy infestation of mold and bacteria. There are also disadvantages like pressure drop. So it will increase the pressure drop and it will increase the fan motor operating cost. Because once your cooling coil is clogged with this biofilm, then it will also affect your fan efficiency. So because of that, because these are all insulated, the cooling coils are insulated with biofilm, you can have poor heat transfer. So you will require higher chilled water flow. And of course, as an effect, the reduction in moisture removal, there is a reduction in moisture removal. So another effect can be shortened lifespan. So if you're looking at your HU to be running at more than 10 years, it can be lesser because you will need to have more chemical cleaning due to this bacteria or fungal buildup on the cooling coil. So that leads also to increased maintenance costs. And of course, the thing that is immeasurable, the poor indoor air quality. So this one is really, it's like, it has a very big effect to the indoor occupants. So UVGI is the most eco-friendly, we can say, for you to maintain your cooling coil clean. So this graph is from ASHRAE also. So you can see here, the UVC has around 260 plus to be 100% 100% effective for germicidal. But the UVC market provider can produce the 254 nanometer, which is close to 260. So this is the common UVC wavelength that is available in the market, the 254 nanometer. So it can reach around 90%, 85-90% efficiency for germicidal effect. Okay. So we would like to share to you the field studies of proven results, how UVGI works. Okay. So the first study I will be sharing to you is the improved air quality, and the second part will be the improvement in performance of HVAC. So of course, UVC has been in the market for 100 over years, but we wanted to make sure that it really works. So a lot of technologies nowadays are present on how we can prove its effectiveness. Okay. First thing is the reduction in microbial count in the indoor air. So this is the study done at Kutek Pot Hospital here in Singapore in 2017. So we have done tests for two AHUs. AHU1 is where UVGI is installed, and AHU2 is the one without UVGI. So the sampling method that we did were swab tests on cooling coil and germ count on airflow after the HU. So the tested microbes are total bacterial count and total fungal count after 4 months of installing UVGI. So this is the test certificate from the IAQ consultant, the third-party laboratory company, and we have translated it to graph for easy visual. So first is the swab test at the fungal count in drain pan. So you can see here HU1 with UVGI, it dropped significantly to 99.6%. And for HU2 without UVGI, it even increased. Okay. Second test was surface swab test on the coil itself. So it has decreased also with 99% for UVG for the HU1. I think HU2 they were not able to get it. There were some some site issues that it was not taken. But you can see here in the HU with UV, it has dropped very significantly. So here is the next is the air sampling test. So we can say this as air quality testing. So the fungal count in the supply air chamber also has decreased to 91.6%. And HU2, it's even almost the same. Another result that we got after 4 months of installing UV is the air velocity. There was an increase of air velocity after 4 months of using UVGI. So that means the fan has been optimized, and we can say that it is an energy saving as well. So you get to keep your cooling coil clean. So that means you also lessen your mechanical or chemical washing of the cooling coil, and at the same time your the air that is pumped into the space has increased. So second test that we have done is at Resorts World Sentosa, Singapore. So this was done sometime August last year only. So we have then done a sampling test to their hotels in the lobby. So we first is the bacteria count. So you can see here we have used URV13. So from that UVGI table, URV13 has an equivalent of 91% reduction of for the influenza virus. Okay, so you can see here the percentage reduction for the bacteria count is around more than 90%. And for the fungal count, it's around more than 90 also. So there could be some questions, why are we testing fungal? Why are we testing bacterial? Why don't we test COVID itself? So the thing is, there is this graph also from ASHRAE that shows, I think I don't have it here, but I can, let me pull out the document to share with you. Just give me a second. Can you see my screen now with the big arrow down, pointing down? Hello? Can you see my screen with the big arrow?
Yes.
Great. So this is from ASHRAE. Okay, you can see here the most susceptible to UVGI are the viruses. Second is the vegetative bacteria, and the most difficult to kill by the UVGI are the bacteria and fungal spores. So what does it mean? If you are getting 90% of reduction for these two, that means more reduction you can get for viruses. Okay, and the laboratory companies that are doing these kinds of testing, they are not allowing us to use the COVID-19, the SARS-CoV-2 virus. It is dangerous. Second is, it is very expensive at the moment. So they say that fungal count and bacterial count are good enough as surrogate index to identify the microbial reduction in the air and in any surfaces. Okay. We have done also testing at Resorts World Manila. Okay. And we have come up to a result. This was a swab test on the cooling coil. So this is after 2 months of installing UVGI. So you can see around 99.99% reduction. So this was also, URV13 also was used for this system. Okay, so another study that I'll be showing you were published by ASHRAE. These are long time testing done. So almost the same procedure as what we have done. It was after 4 months of installing UV, and they have tested total fungal count and total fungal spores in the air. So there were study floor and control floor. Study floor is with UVGI and control floor without UVGI. So you can see here, study floor column and control floor. So with study floor, you can see a very big difference also of reduction of these different types of fungus. And for the control floor, it even increased. So fungal spores reduction. So yeah, those are the studies for surface and air quality using UVGI. So another study that we wanted to share to you are the improvement in performance of HVAC. So we wanted to prove that there is a better heat transfer and energy savings. So this study was done by NUS Singapore in 2017 with the support of the Pennsylvania State University. So it was William Banflett was the president that time of ASHRAE, and they have worked with the professors in the NUS with Iwang, Mr. Chandrasekhar. They are very they were the leader of this testing. So they have done the testing in 4 months long of experiment, okay, with just to identify or to learn that UVGI really helps to save energy in aircon system. So the UVGI was installed in front of the cooling coil. That is where it is supposed to be, because after your cooling coil is the wet side. So these are where the fungal and biofilm growths. These are where the bacteria, fungus, and all the biofilm build up. Okay, so the test objective is we wanted to know whether there will be biofilm buildup on that side of the cooling coil. So of course, the biofilm buildup will cause the pressure drop, the increase in pressure drop that can be, more of that will increase the operations costs. So that they wanted to identify if how UVGI will affect and will improve the system. Okay. So I wanted to go further to this result that actually this biofilm, these are the thermal conductivity. These are the thing that can happen when you have biofilm buildup. It will act as an insulator on the surface of your cooling coil. So after the testing done, the air side heat transfer coefficient has increased to 16%. So that's how the heat transfer has improved at the cooling coil. So these are the summary of the results during the study. So increase of heat transfer coefficient by 16%. So there had been lower pumping costs. So that also turns into energy savings. Okay, improved chiller efficiency. That also translates to energy savings. And of course, because you have good heat transfer, you have an improved cooling, and you have done a lot of moisture reduction in your cooling coil. So that means it leads to lower RH in occupied spaces. As we all know, the maintained RH in the comfort RH in the space is around 60-65%. So that they need to reach, or that's their goal also. So second study was done in Tampa University. This was a Tampa site in the US. So this is the actual coil surfaces before they did the study. The same thing. The study period was 14 months before UV and after UV installation. So they have found out that using UV after 10 months of installing it, 4 months was the testing of getting the data of how the cooling coil performs without UVGI, and after 10 months that the UVGI is installed. So there was a decrease in mean coil air side. There was a decrease in pressure drop, in short, okay, of 21%. And increased in mean overall heat transfer of 14.5. So you can see the previous testing at NUS, there was an increase of 16%. And this study at QS has a result of almost 15%. So that means there is a proof that this can be duplicated to other system, even to your building, if you're using the properly selected UVGI system. So these are proofs that there is an energy saving with the use of UVGI, and there is a germicidal action. It is true that it can reduce the microbes in the air and in the surfaces. Okay. So all the reports mentioned are installed. The UVGI were installed inside the AHU. Okay. So I would like to share with you also what are the features or what you should be looking at when you are when you wanted to use UVGI system. As I have mentioned earlier, the testing done on those studies were inside the HU, and you know the temperature and the condition inside the HU in front of the cooling coil is very damp, cold, wet, dark. So that's why it is very important that the fittings of your UVGI is at least IP65 or IP65 and very protected from any condensation. So with Spectra, we have our own software to generate these the kill rate factor of the UVGI. Okay. And would like to share with you also that these are all extracted from ASHRAE handbook. They say that in providing, the providers of UVGI should improve their system to address the wind chill effect. So what is the wind chill effect? So whenever UV is installed in front of the cooling coil, you are dealing with the temperature around 10 to 12 degrees C. I'll make it a little bit bigger. Okay. So when the temperature is around 10 to 12 degrees C, your UV output is only around 55%. So that means you are losing 45% of the UV power. Some more, if your system, I mean, in front of the cooling coil, you are also dealing with wind velocity, which is around 2.0 meter per second or 400 FPM. If your velocity is at this level and with 12 degrees C temperature, your output can only, the UV output can only be at 40%. So you are losing 60%. So how to deal with this? Because if you wanted to use UV in your system, you wanted it to be lasting long and performing as you require or as it is intended. So here we have corrected that factor of improving our UV lamp. So you can see here, this blue line is a conventional UV system. So you can see from 7 degrees C to 10 or 15, the UV output is very low compared to the improved UVGI, that it is consistently, the UV output is consistent from 7 degree to 23. Of course, the higher the temperature of the air, the better your UV will be performing. But if you intend to put your UV light inside the AHU in front of the cooling coil, you must be very aware that it can have losses if it is the conventional type of UV lamp. So this is an example of how it looks like whenever you installed it in front of the cooling coil. So you can see here this condensation on the surface. So with Spectra, it is IP68 and it is provided with quartz sleeve. Actually, many UV manufacturers are providing this. You just have to be keen on this, because if you don't use this quartz sleeve and non-IP rated connection, I assure you that your lamp will only be working for a few days and no more. You will be just wasting your money. So it's better for you to check your lamp system that it is very well protected for this wind chill effect, which is very much recommended by ASHRAE to that UV provider should be providing this wind chill corrector. So this is an example of IP68 leak tight lamp head, and this is the quartz glass. You can see this is the lamp itself inside, and this is the quartz shield that is protecting the lamp itself. So this quartz shield actually has can improve the performance of the lamp to almost 2.8 times 2.8 of this. You can see here in this table. So the difference is almost 2.8 from 70 to 196 UV output power. Okay. So I think these are more of our systems. And yeah, just would like to share with you all these the various models for various types of installation at site. Because the thing is, these are all the ladder mount models that can be installed inside the HU, and we can also do for ducting. Okay. So this is how it looks like. Of course, as per ASHRAE also, they recommend that materials to be installed inside the HU with UV should be UV proof. So materials, whenever you select your UVGI system, you must be very keen also of your supplier's materials, that it is not rubber, any polymer material exposed to UV can easily get degraded. Okay, and of course, UV exposure. This is as per ASHRAE also, that as much as possible, UV manufacturers should be very keen on the safety features of the UV of the system. So because it can easily get human exposure, human exposure can get severe burns or even blindness. So there are safety features that your UV provider can give, such as door switch, yeah, those kinds of safety device. So yes, so of course, UV safe wiring, leak tight lamp head for long lasting operation of your UV, quartz sleeve for almost ×3 performance, and high effective polished aluminum reflector. This is if your purpose is to keep your cooling coil shining, and of course custom mounting for your UVGI casing. So these are the safety features that you may look for from your UV provider. This safety label is a must actually. These are put on the access door to the UV, commonly at the door of the cooling coil, and this door switch. So the thing with this is it's interlocked. There's an interlocking that whenever you open the door, the access door, it automatically turns off the lamps, and when you close the door, then it turns on. So this is the safety. Of course, whenever you go to, say for example, you wanted to do maintenance of your UV light, it is a standard thing that you must turn off the control panel of your UV, or you must turn off everything in the HU. But some people, they forget, or they just wanted to open the door anytime. So to prevent them to be exposed to UV light, this door switch should be there. Another thing is this is shatterproof encapsulation for lamp. This is another feature. It's not all that. It depends on the customer whether they wanted to use this, but at least you can find this feature also with some UV supplier. This is to prevent the lamp to be totally, that it will scattered on the floor whenever it breaks. So with this, you can still, even if it is broken, it is still intact with this encapsulation. So yeah, there are different types of control panels also available. It depends on your customer's requirement or your requirement itself. This is an actual cost and payback calculation by in one of the hospital in Malaysia, and this is the summary of it. So since there is an energy savings effect using UVGI, we have calculated that in terms of around 15 to 16% energy savings on the chilled water, and due to heat transfer. So both there are two types of energy savings: chilled water pumping and the heat transfer. So yeah, total of 46 HUs, and there are 94 numbers of UVGI lamps. There is electrical powers saved per day of 1,008. And it has come to approximate payback, the same simple payback analysis of around 1 year. So we have done also one study here in Singapore, one of the new buildings being constructed, and around 75 HUs with some, around 12 hours of operation, because this one is a hospital, so it's 24 hours. So for an office building, we have come up to a payback period of around 3 years. So 3 years is still okay, because actually we assume that the installed system of UVGI will be there as long as your HU is still running. So you only need to replace the lamp tube itself, nothing more. Okay. So ballast, maybe you can replace it probably after 5 years. So if you are intending to, if the life of the UVGI system is around, if the life of your HU is 10 years, it's only 2 times that you will be replacing the ballast. The lamps, our lamps the lamps lifespan can be around 13 to 16,000 hours. So that's roughly 1.5 to 2 years. So these are the possible locations or installations of UVGI. inside the HU. Okay. Of course, if it's a new HU, it's easy to be installed. For old HUs, if they have space of around 600 mm, then it's possible to install it inside. The recommended distance from the cooling coil to your UV light to maximize its irradiation is around 300 mm. Okay, because the farther it is, the more coverage to the cooling coil the UV can ray. So if it is like closer to the cooling coil, there could be some dark spots on the cooling coil surface. So that's what we wanted to prevent. That's why we recommend around 300 distance.
Miss Joanna,
Yes.
is it upstream or downstream of the cooling coil?
Downstream.
So the air is cold already, then it will touch your your UV lamps.
Right. Yes. So the reason here is we wanted to prevent the biofilm buildup on the wet side of the cooling coil. That's why it is installed downstream. Okay. So yeah, these are the types. Actually, in the I would like to share with you that because of this COVID, the conventional way of UV design, like 3 years back, before COVID back, a year back, okay, to be exact. This was the old design because previously there was no COVID and we only wanted to keep the cooling coil clean. So using the reflector, you can maximize the power of your UV light to keep your cooling coil clean. But because of COVID, you wanted to do surface and air disinfection. So that's why we have this 360 model whereby whenever the air passes through, all of them are disinfected with by the UV. So it doesn't have any reflector. So any air that passes through, it's all sterilized by the UV. Okay, like this. So this is an actual installation in Singapore Airline. Singapore Airline House Office. So this is 2 columns and 10 lamps. Yeah, total of 10 lamps. So you can see here, these are all metal conduits. So no rubber. This is a metal conduit as well. So it's a metal coated with PVC. So you can see no rubber exposed to UV light. And then here the hand, it bypassed the door switch. Because whenever you just open the door, then the lamps will automatically turn off. So we just bypassed it. We push the door switch in so that the UV light will turn on. So of course, different types of control options. So these are it is possible that you can also install UV in the duct because sometimes HU, you don't have any space in the HU. So you can also install the supply air duct. It depends on how big or how accessible also is your ducting. Okay. So I wanted to share more. Okay, this is the control panel options. So if you wanted to have simple on and off, if you wanted to have LED light to monitor individual lamp, you can also have that. If you wanted to have BMS remote on and off from BMS, that is also possible. And then if you wanted to have a timer function for individual lamps, say for example, you wanted to know whether your UV light has reached the 16,000 hours. So for you to know that, you should have a timer function in the control panel. So it counts the the time of operation of your lamp, even if you on and off it, because it has a built-in battery in the control panel itself. So in that sense, you would know whether you don't need to log in manually of how many hours your UV light is working. So you will just set it to the time lamp life that you wanted, maximum lamp hour that you wanted, and then it will give you the fault signal whenever it is due for replacement. So yeah, so some market practices that you don't want to use, you don't want to see in your own system is this kind of connection. So water condensate can easily get in, and in no time your UV light won't be working anymore. Okay, of course, plastic cables. And you also don't want this aluminum foil leak tightness here. Okay, these plastics exposed to UV. This kind of ballast installation is very dangerous because as time goes, ballast is heating up. Whenever your UV light is working, your ballast are heating up. So it can cause electrical shock shortage, and your UV can get spoiled also. Okay, this type of connection, all exposed. Okay, and yeah, so these are the project references that we have internationally. We have in Singapore. Hong Kong, actually, they have, I think UV light is already a standard in all their buildings. So Hong Kong is one of our major customer. Of course, Singapore. We also have projects in Dubai, Australia. Yeah. So yeah, so that's it only for our UVGI system. Do you have any questions?
Miss Joanna,
Yes,
I saw earlier that you have an option of installing this UVGI at your ducting system.
yes.
What's the difference between installing it near the coil or installing it at the duct?
Okay, that's a good question. When you install in the coil, you have a benefit of cooling coil cleaning and air disinfection. I'll just go back to that options. Yeah. So whenever you install it in the HU, you have two benefits of energy savings and cleaning on the cooling coil and air disinfection. If you install in the duct only, you're only getting air disinfection effect. You don't have energy savings. Yeah, so that is only the difference. But if you want, if your purpose is for air disinfection, both can happen to both type of installations.
Does it matter? Does the air velocity on the duct matters for your system, or you will adjust according to my?
We adjust our system to the air velocity,
So
whatever.
So you will provide the appropriate amount of lights to accommodate the duct velocity.
Right. Yeah. Exactly. We will select our lamps according to the air velocity, air capacity in the duct, or even in the AHU. Yeah.
Would the maintenance program be similar in frequency if I install it on the duct and versus I install it on the coil?
Yeah, it's the same. Normally for UV light, you always consider the operation hours, the lamp life of the lamp, the lamp life. So say for example, your supplier or your provider's lamp can your provider's lamp life is at 10,000, then the maintenance will be after 10,000 hours. So yeah, that's only how it works when it comes to maintenance.
do I change my lamp regardless if it's working or not, if it's over the estimated life lamp already?
Yeah, very good question. Because say your UV supplier is claiming that their lamp is at 10,000, their lamp life is at 10,000. It can still be working after 10,000 hours, but the efficiency drops to usually drops to 80% only. So if before it was running at 100% efficiency, after 10,000 hours, 80% na lang siya.
Okay, thank you.
You're welcome. Yep. Any more questions? So it is very good to know that on your side, whenever you ask your UV provider for the selection of the lamp, it is good to know to get a data sheet from them as proof of dosage that they are offering to you, the intensity, the UV power, electrical watt. So there are some guidelines of what are the high output, standard output lamp, so you would know whether it is really effective for your system. Yeah, so I think those are these are also the important whenever you do the selection or you request your suppliers to do selection for UV light, it is important that end user should give what URV rating or what is the intensity rating of the UV that you require, so that they have the reference of selecting the UV. Yeah. So, any more questions?
Any more question, guys? Kung wala nang question, no? Maraming salamat, Ms. Joanna. Thank you very much, Ms. Joanna, for giving us the opportunity to learn more about UVGI. So, if you guys want to learn more or you have any inquiries to Ms. Joanna, you can send them to me, or you can send. I will forward the inquiry to Ms. Joanna. There you go.
Thank you.
I will also, for those who have registered for this event, I will also forward the registration form to Ms. Joanna, so that in any case she can what do you call this? If you in any case she could send to you or tell you or inform you about new products coming from Envirotech. Okay.
Thank you po.
Okay. Maraming salamat. Thank you everybody for joining us for tonight. And for those who have, I will just same as always, I will provide the slides. We will provide the slides and we'll provide the recording of this training session for you guys to follow up in the future. Okay. So if there's no more questions, then I guess this is it. Thank you very much. Good night and stay safe. Miss Joanna, could you stay for a little while? Thank you.
Sure. Thank you. Okay.